Hello, everyone. Please join me in welcoming Mary Grace Moesta, who will be talking about MLOps deployment patterns with Delta and MLflow. Thank you, Mary Grace.
Hey, everybody. I understand it's the end of the day on Thursday, so hopefully I can keep you guys entertained and short and sweet and informative. So as she said, I'm here to talk a little bit more about deployment patterns and specifically how Delta and MLflow, two open source pieces of technology, can be really helpful in managing some of the pieces of deployment. In terms of what we'll cover, I'll just do a brief introduction about myself. We'll kind of frame things a little bit by talking about why you should care about MLOps deployment and why it can be really difficult and challenging. We'll do a quick primer on Delta and MLflow just so everyone's kind of on the same page in terms of understanding the basics of the technologies. We'll then go through kind of the deployment patterns, outline what those look like, and then really dive into talking about how Delta and MLflow specifically can help with the reproducibility pieces of the deployment patterns, the audit pieces, and some additional deployment optimizations. And then at the very end, we'll kind of have a brief discussion on CI/CD. Like I said, my name is Mary Grace Moesta. If you can't tell by my slide, I'm a Taylor Swift fan. But I'm a senior data science consultant from Databricks. I've been there for about over 4 years now, where my time there is spent doing a lot of all things data science. And recently, it's been quite a bit of MLOps and ML engineering type work. I'm based in Detroit, Michigan, so the sun and no snow here in Seattle has been a really nice change of pace. All right, so let's kind of dive into it and talk about why ML deployment is hard and start by talking about why you should care. Now, if you're in this room, my guess is you probably care about it a little bit, maybe not at all. If not, hopefully after this slide you care. Like I said, I'm a practitioner at heart. So to me, the fun parts of data science are the exploratory work, the hyperparameter tuning, the modeling. Trying out new algorithms is like I said, that's all the fun pieces. But when we kind of go back to like why we're doing all of this, it's really to deliver value to someone, something, or some entity, right? And unfortunately, the building of models isn't always super valuable, but the delivering of those models is what's really driving the value. Delivering the models is deployment. So how we can bridge the gap between the fun parts of data science and the value is deployment. Now, when we think about well-rounded deployments, what does that mean? Couple pieces here of like what I think of when I think of a good, well-rounded deployment. The first are the fact that the results are really high quality. So as you move up in environments, from dev to staging to prod, so does the quality of your artifacts across those environments. And the second piece, and I'll kind of reiterate this like several times throughout the presentation, but it's an automation first mentality. So automating your processes through the deployment process is kind of twofold. First, it contributes to that high quality or high fidelity results in the sense of the less manual processes you have, the smaller room for human error, which again kind of furthers that quality in your production environment. And the second piece is just saving people time, right? Like if you have these really intense, manually intense deployment processes, that's time you're taking away from other projects, from other people. So automating it kind of, again, provides that quality piece and also saves a whole bunch of time. The other thing is about deployment and the development of new features into your system. So when you have a well-automated, well-rounded deployment solution, doing things like adding a different feature set, changing your hyperparameter tuning optimization techniques, right? All of that becomes much easier to implement and roll into production faster if you can just change your code and plug it into the rest of the process and it deploys smoothly without anyone having to touch it, without having to wait on anyone's approval. So now hopefully everyone cares about ML deployment. Let's talk about why, again, it's not easy. And this is kind of, again, a summary of like what I've seen in my experience, but the first piece is there's always a learning curve associated. And so deployment kind of comes in two different ways. We see sometimes data science teams are responsible for deploying ML systems. And the learning curve there is oftentimes the data science community isn't super familiar with automation and CI/CD tools. So there's a huge learning curve of trying to get up to speed and just trying to wrap your head around what the heck is Jenkins, how do I use it, and how can it be helpful to me as a data scientist. On the other hand, when we have these like DevOps or deployment teams responsible for developing the models, they're sometimes not super well versed in data science. So like the nuances of deploying a data science system have to be learned as well. So there's like the data science piece of that learning curve when we see the deployment happening by a deployment or like a CI/CD team. So that kind of, again, makes things a little bit more challenging because there's always something new that someone has to learn to be able to do this. The other piece, I think one of the larger ones is, again, with any ML experiment, there's so much to keep track of, right? You have the model, you have the data, you have the environment, you have any compute resources, you have any additional artifacts you're generating from that modeling process. And so keeping track of these artifacts across environments can be tricky in itself. But you also have to think about the iterative nature of ML, right? We're building different versions of these things as we go through different environments. So not only do we have to manage them across environments, we have to manage those versions so they all fit together really nicely. We need to have the version of the model match the right version of the data, match the right version of the environments, and keep moving that through the entire process. It gets really delicate and really challenging. So again, being able to answer these questions of like, what feature set was my model trained on, which version of data was my model trained on, gets really difficult as the number of artifacts start to grow. Okay, so we've kind of framed things up a little bit. Let's talk about Delta and MLflow. So if you're unfamiliar with Delta and MLflow, they're both open source pieces of technology. I'll start with Delta. So Delta itself is an open source storage format, or framework rather. And the easiest way I like to think about Delta is versioned Parquet files with a transaction log. So if you're familiar with Parquet, think Parquet first, right? We get all of the great benefits of Parquet, the compression, we get all of the metadata that's tracked in the headers and footers of Parquet files. That's awesome. Now, when we add this versioning on top of that, what we get is we get the ability to look and see how those Parquet files have changed over time, which can be really helpful when we think about matching those versions of models to versions of data in the deployment process. And then on top of these versionings, we have the transaction log, which is kind of like the single source of truth. It's where all of the operations against the table are tracked. So you can see how these versions are changing, but you can also see who's making these changes, right? Who is rewriting, overwriting these tables, who's merging certain tables, which again can be really important when we think about access to data in upper level environments. In terms of interacting with Delta, it plays really nicely with Spark, which if you've seen Delta, you've probably seen it in context with Spark. But it also plays really nicely with a couple other things. Namely, it plays really well with Python because of some of the Rust bindings. So we'll talk about that in a little bit. And then MLflow. So MLflow is, again, another open source framework that is designed to make managing the machine learning lifecycle easier. Now, that's like really kind of salesy and like me just like waving my hands of like, oh, it's like all great, it makes everything better. But I'm going to attempt to explain it and kind of show how this actually works. And so there's several components to MLflow, but the components are really designed to address different parts of the machine learning process. So the first piece is there's a tracking or like a logging API with MLflow that can be really helpful in experimentation and reproducibility. So as you go through and are generating these different parts of any data science experiment, think your hyperparameters, think the model, think the data, think the feature set, think the environment, think all those things, right? Those things can be logged directly to this MLflow tracking or this logging API. So again, you can keep track of all of the metadata that's associated with a model itself, which contributes right back to reproducibility, right? As we think about moving this model across different places, we have all of the necessary metadata to reproduce those results in upper level environments. The other pieces of MLflow, again, can contribute to making deployment a little bit easier. And this is one that I'm going to kind of like wave my hands at right now and say that just bear with me for like 4 slides and I'll explain this, I think, in more detail. But essentially the way that MLflow can package up these models and make them much more self-containing means that we can avoid a lot of the dependency management or dependency frustrations, I should say, when it comes to deploying models down the line. And then one of the last pieces of MLflow is there's a model registration component. And so again, this is thinking kind of the same way that we are versioning data with Delta. We are versioning models with MLflow to be able to track which models and which versions of certain models are at what stages of the process, right? So knowing which models are in development, which models are in production, which versions of which models are in development and production. All of that can be tracked, like I said, through that registration piece. The other nice part of MLflow, it's kind of bring your own framework in the sense of there's no dependency of having to rely on only training models with sklearn. You can bring sklearn, you can bring a custom algorithm, you could bring TensorFlow, Keras, PyTorch, anything can play nicely with MLflow. So you're not really limited in like whatever library you're using. It, like I said, will play nicely with MLflow there. And then in terms of interacting with it, right, there's a lot of ways to do it. We'll rely on Python, but again, there's CLI, Rust, R, and Java, and all that good stuff. Okay, let's talk about deployment patterns now. So there's really three main deployment patterns that we see. And all these deployment patterns are shaped around which artifacts are being moved, right? That's kind of the first question you should always ask yourself is which artifacts am I moving across different environments? And so these are kind of in no order at all, but the first one we'll start with is deploy model. So again, we're just thinking about the flow of artifacts right now. We're not thinking about the automation of how these things are flowing, just like the pattern. So in the deploy model scenario, that's where, again, you train your model in your dev environment. This kind of relies on the fact that you have access to production data in dev, which might not always be the case. Sometimes it is, sometimes it's not. But you train your model in dev, and then you take this model binary, and that's what's moving to staging. You maybe run some tests in staging. Your tests pass and you move to production. But that binary is what's being moved across environments. The second one is deploy code. Now, this one can be much more helpful, especially if you're in a scenario where you don't have access to production data in dev, which again happens a lot in like regulated industries, especially when you're dealing with like personal health data, all that kind of stuff. So the deploy code mechanism or pattern rather, is where your code is moving from environment to environment. So you have your dev environment, your code is developed there. You go ahead and merge it to staging. You run your unit tests, your integration tests in your staging environment, and then pending the successful running of those tests, you push into prod, and in prod, your entire model pipeline is retrained. So again, that's where you can have access to your production data. A service account has access to your production data. You can rerun the whole pipeline, but by just moving, like I said, that code. And then the third is a hybrid approach. It's some version of both. In terms of like the patterns of these, again, these kind of vary just depending on the scenario and permissions and things like that. But it's really some version of deploying both the code and the model throughout the process. So an example of this would be like your model is trained in dev. You promote your model binary and your code into staging. You run all your tests, and then you go ahead and only promote your code into production and retrain your model in production, and you can access production data, all that good stuff. Thing to think about here, especially with the hybrid approach, is much like anything else, the more things you add, the more complexity you get, right? Moving one box is easy, moving a whole house is a little bit harder. So as you increase the number of artifacts that you move, you have to understand that there's likely gonna be an increased cost to automate that process. Now, it won't necessarily be linear, right? Because likely the mechanism you use to move one artifact, you can use to move multiple, but that's just more pieces of the puzzle that you're moving together. So something to think about as you are kind of understanding which artifact you're moving across different deployment patterns. Okay, we talked about deployment patterns. Let's now bring this thing together, right? Where do Delta and MLflow fit into this piece? So one thing, again, that's really important that I've kind of started to talk about is this idea of data reproducibility. So when we're trying to reproduce a model or trying to move it across different environments, we have to be able to map versions of data to the model. The same way that you need lineage in data engineering, you need that same lineage in machine learning, except it just is a little bit different, right? It's lineage between your model and your data and any other artifacts. Now you'll see the diagrams for both deploy code and deploy model on here for kind of how the versions are important. This is also still relevant, I want to be clear, for the hybrid approach, but that diagram just gets way too messy to put on a slide. The gist here is that regardless of whatever pattern you're looking at, the need to version your data to be able to map which data goes, or which version of which data goes to your model or to your code is incredibly important. So let's look at the deploy code, for example. We build our model or build our code in our dev environment. We have some version of data that we want to check in there. Same thing, the code gets promoted, we move to staging, maybe run our tests on a different subset of data, and then finally, as our code moves through production, we are training our model now on production data, but have to have a certain version of production data. And the other thing to think about here too is the permission structure is changing, right? We shouldn't have users have access to data in our prod environment. That's likely going to be service accounts. And so having that audit path of who is accessing what data when is also going to be really valuable, especially in these highly regulated industries. So this is where the Delta piece really starts to come in. So like I mentioned before, Delta is versioned Parquet files of the transaction log. And this combination of the Parquet files plus the transaction log allows us to do what's called time travel, which is the ability to view historic versions of the data. So again, this is the piece that allows us to take a model and map it directly to not only a table or a location of files, but the exact version of those, whether that version is done by a version number or even a timestamp. So again, if you say you have a model that was trained 2 weeks ago, you need to reproduce it into a different environment or for like audit reasons, you can say, I want to look at my data of what it looked like exactly 2 weeks ago to be able to fully reproduce the results of this model. And so one of the other pieces here is, like I said, that transaction log tracks a whole bunch of other things besides those versions of Parquet files. It tracks a bunch of metadata of things like who has access to what. So when we think about tracking any events against the table, we can ensure that the right users are touching the right data in the right environment. So again, in dev, we would expect our data scientists to be the ones creating tables, merging tables, overwriting them, et cetera. But as we move into those upper environments, we would expect that only to become things like service accounts, right? That like humans don't have access to, or that humans are not touching the data that service accounts are, to ensure that we are producing those high fidelity results of that well-rounded deployment system. So you've oftentimes probably seen, if you've seen Delta, you've seen it a lot of times coupled with Spark. But not all ML requires the power of Spark, right? But all ML requires this reproducibility piece of data. So all of them require Delta, but we don't need Spark. And so there is a Delta RS library, which is Delta RS provides rather the Rust bindings, or the Rust base for the Python bindings, which means that you can just use vanilla Python and Delta. You don't need to be using Spark anymore. And this plays right into the Pandas integration. So in data science, right, Pandas is pretty much the standard for single node data science. So you can read from Delta directly to Pandas using the Delta table APIs as well as the two Pandas functions. So you result with a Pandas data frame. And then in the reverse, if you have a Pandas data frame in memory and want to write it to a Delta table to get that versioning, to get all of the access to that metadata in the transaction log, you can do that using the right Delta-like function too. So Spark is no longer needed. Spark is not only the way to interact with Delta. You can interact with it using vanilla Python. OK, let's now talk about MLflow deployment optimizations. So I kind of waved my hands earlier. This is where I actually start to tell you, explain a little bit more why. If we think about making deployment easier, the number one thing that's going to help us is we need to identify what we need for deployment, right? What do we need to move things? How are we going to move them? In all of those pieces. So to answer that question, it's going to be entirely dependent on your pattern, right? If you're deploying code, if you're deploying model, if you're deploying some hybrid of both. But regardless of whatever pattern you're using, you will likely need to deploy some aspect of your code, of the model itself, of the hyperparameters. You'll need to keep track of the metrics, the environments, all of that stuff, right? And that's where that logging API really comes in. You can track all of the metadata that's associated with your experiment. Again, those things that will be required for you to recreate in upper level environments as part of the MLflow, that tracking API. And so on top of that tracking API, when you log models, there's actually this, like I said, that packaging format kind of comes in, which is what you're seeing on this screenshot right here. So this is a model that I built and logged in MLflow, just like a vanilla sklearn model. And there's a lot of things that are logged here, but I really want to call attention to these flavors. So you'll see that at the bottom, just below the purple box, there's what's called, and it's a little hard, but it says sklearn here, and it's the native flavor, I like to call it. But every time you log a model with MLflow, two flavors are logged. The native flavor, which you'll see here. So you can see that it's, again, the sklearn model, serialized with Cloud Pickle, gives you the version of Cloud Pickle. Awesome, right? I can now serve this model on anything that's going to be able to understand an sklearn and use an sklearn model. But you'll see the second flavor that's logged here is a Python function. And there's kind of twofold value to this Python function. The first is that you'll see the Python function is self-containing. So it points to a conda YAML that includes all of the required dependencies needed to use this model for serving. So it includes, like I said, the conda YAML, and it points to the MLflow loader module, which is really the wrapper around sklearn to be able to load this model in and out of of using just Python, the prediction function, and the Python version. So the nice part here is I can now take this model and serve it on anything that understands Python, right? I don't have to worry about making sure my VM or my deployment region understands an sklearn model and can manage all those downstream dependencies. If it's got Python on it, I am good to go and good to serve. So it kind of opens the door and eases that burden of all of that environment management by logging this Python function. So that's kind of one value piece of this Python function. The other piece is kind of pertains more to like the version or the inference at scale. So like I said, I deployed this model with train this model rather with sklearn, just a regular single node model, right? But this Python function actually has a vectorized UDF that's built in, which means that I can use this to distribute my model for inference. So again, I built this model with sklearn. Say I need to now apply it to gigabytes, petabytes, terabytes of data, right? I need to scale this model out for inference. I don't have to change a lick of the training code, right? I can keep the training code as is. I can use this Python function, leverage the Spark UDF in this Python function, and then apply inference across an entire cluster of machines to do inference at scale. And so the way that this actually works, this vectorized UDF works, is it uses Apache Arrow underneath the covers to really minimize the serialization costs between the JVM process, which is what's happening in Spark, and the Python process, which is happening on top of the JVM. And if you're curious to know more about scaling code and kind of these vectorized UDFs, there's actually a talk tomorrow by some colleagues at 10:15 that will talk much more about kind of scaling this single node code with Spark and Pandas. So this, like I said, this second part of the Python function of having this UDF can be really useful when we think about scaling out inference of a single node model. Okay, let's talk CI/CD. Candidly, CI/CD scared me, I should say, past tense. Like I said, I come from like a data science, math background, automation tools, just like were not really exciting to me, which is why I have this like GIF of SpongeBob like clutching a pencil. This is me like trying to be like, what is Jenkins? So to provide a little bit more context, let's revisit these deployment patterns, right? Last time we talked about them, we talked about how things move, just like the pattern of which things move. Now let's layer in some more complexity. Not only do we want to know how these things move, this needs to happen in an automated way, right? We need to be able to move my model or move my code or move both without me having to touch anything or touch maybe one button per se. So this is where, again, we revisit this idea of being automation first. So regardless of whatever artifacts, like I said, are being deployed, whether you're going through the deploy code approach, the deploy model approach, or the hybrid, there should be automation that's going to move these things from one place to another. So again, if we think about the deploy model piece here, we're deploying that model binary, right? There's some level of code management, again, using whatever flavor of Git you want. But then there's also going to be, again, that automation piece that's going to move the model, physically move that model from your dev environment to staging, run your tests, and then move it from staging to prod, and then run your jobs in prod. In the deploy code sense, right, similar idea here, except we're deploying code, right? So there's, again, another level of code management. We have our code in dev. This is where the branching structure really comes into play here, of managing branches across dev, staging, and prod to kind of point automation in the right direction. And then again, with deploy both, these patterns kind of vary, but same idea, right? There's some level of code versioning that needs to happen, and then a level of movement of these artifacts. And so beyond the automation piece of the movement, the other important piece here is triggers and triggering. And so triggers are really what's going to kick these things off, tell the automation to say, hey, this is how we get started. And so I'll take kind of deploy code as an example here. So if we think about that deploy code approach, we write some code, commit it to our dev branch. We then create a pull request from dev to staging, and that pull request can act as a trigger. So that pull request is going to tell my automation server to say, hey, okay, let's move this code from dev to staging, let's run my tests. Pending those successful tests, we can merge that branch together, and the successful merge from dev to staging can kick off another PR that's going to merge the code from staging to prod and then deploy the jobs into prod. And all I had to do was create one pull request to dev, and it moved my code and deployed my code all the way into prod. Right? So those triggers can be really important. And that's why you see oftentimes like PRs, especially when you're deploying code, really common trigger because that honestly kind of make one PR, and it will can carry you through the rest of the process. Pull requests are one of many ways to go ahead and define triggers. You can do API requests. There's a lot of ways. There's webhooks you can integrate with, but definitely for deploy code, pull requests is a really useful tool to lean on. This chart is not exhaustive at all. This is just kind of, like I said, some common tools. CI/CD encompasses a lot of things. And I kind of want to just, like I said, call your attention to a couple things on here. We'll start with orchestration. So again, when you think about like what's going to be that mechanism that's going to move things, to set up the trigger and move things, Jenkins can be a really useful tool for that. It's open source, so it plays nicely with a lot of things. There's also, like I said, several sort of managed solutions. Most of the code versioning softwares or products like GitHub, Bitbucket, Azure DevOps have their own like automation server associated. So like Bitbucket has pipelines, GitHub has GitHub Actions, and DevOps has DevOps pipelines. So again, depending on kind of what you're using for code management, you can kind of stitch together the right CI/CD tools, or the right automation tool, I should say. On top of that, again, there's some notes on here about like webhooks. So again, webhooks can be another means for triggering certain things depending on like what your process looks like. As well as like testing frameworks and stuff, like rely on PyTest for, honestly, I rely on PyTest quite a bit for running tests and staging in production. But like I said, this is not an exhaustive list. It's just kind of throwing a couple things out there. So when you see these tools, you kind of know how and where they fit into the process. The last thing I'll talk about on this slide is the MLflow projects piece. So again, that's like that MLflow model I talked about of easing the burden of environment management by packaging all of your ML code into one cohesive project that contains the environment. So you can just, like I said, deploy it on whatever your deployment mechanism is, whether that's a virtual machine, whether that's on-prem, whatever it may be. Okay, so how do I approach this? Like I said, automation first is like the whole mentality here, right? There's no, unfortunately, I wish I could tell you there is, but there's no single right way to stitch all these CI/CD tools together, right? There's so many of them. In terms of like how to approach, like where do I even start? Honestly, security, I hate to say it, no offense to anyone in security, but security can approve or disapprove of a lot of technologies. And so I've been in a lot of situations where people are really passionate about using a certain tool, but for some reason security says, nope, we use this other one here. So if you're ever looking to know, okay, where do I even start? I would recommend talking to your security teams and seeing what's approved, what's already in use. The other things to think about are things like, do you want to stay open source centric, right? You can do all of this with open source tools. You don't necessarily need any of those managed tools. Things like latency requirements can be really important here. So if you're serving a real-time model, understanding how that can contribute to some of the automation pieces in here. And then the last piece I would say is like unification, especially like I'm sure a lot of software engineering teams already have automation in place. Rely on those folks, right? Like they have quite a bit of knowledge of what tools are already out there and already exist in your ecosystem. And providing that consistency, again, kind of lowers that learning curve that's necessary for any deployment piece. Oops. Okay, wrapping things up. So we talked about the deployment patterns. Again, this is all defined by the artifacts that you're moving. So when you think about where do I even start, think about your artifacts first, right? Put it in terms of artifacts. And then we talked about kind of regardless of that pattern, those data audit pieces and the reproducibility pieces of your data is super important. And that's where you can really lean on Delta and not like versioned Parquet files of the transaction log to lead you through there to provide that lineage of model to version data. I talked about MLflow, like I said, but I didn't honestly talk about every piece of MLflow. We didn't really touch too much on the registry, which is, again, kind of another piece here. But amongst many other things, MLflow can provide some of those built-in optimizations. So that's that vectorized UDF and that Python flavor or Python function flavor, as well as the tracking to track all of your metadata to further help that story of reproducibility as you shift your artifacts across different environments. The last piece, again, is CI/CD tooling. Ironically, it's designed to further simplify. Sometimes I feel like initially it's more complex than simplifying things, but longer term, right, it's designed to simplify and automate your deployment processes. So keeping those couple things in mind of like where to start of those tooling, really all about going to be like security-centric, unification, all of that stuff. Last thing is that GIFs are much easier to put in a slide deck than I ever thought. I don't know why I thought it was like really hard. Turns out it's just copy and pasting a link if anyone's new to that. But yeah, that's all I've got for you guys today, or for everyone today. I think we can now open to questions.
Thank you so much, Mary Grace. Any questions? Oh, let me.
I just had a quick question about Delta and like the Parquet files. Like, are the Parquet files stored with your models then, or like how does that happen?
Yeah, so you can essentially track the version numbers as part of like a piece of metadata that's tracked in the MLflow experiment. So you can log your data, right? But what's really happening when you log things is just logging to blob storage on the back end. So it can be redundant. So the easiest way I found to do it, honestly, is just taking that version number or timestamp, logging it with your MLflow experiment, and then you can access, like you directly can access like that version. You can also log like the path too, right? So you have the table path and the version. Yeah.
Awesome. Any other questions?
Just as a follow-up, does that mean that in order to use data versioning via Delta, or is it Delta Lake? No, Delta, right? Delta. That we have to use MLflow?
No, so you don't necessarily have to, right? It's all about like bridging that. You can use MLflow without Delta. You can use Delta without MLflow. They're independent of each other, but they work together to like be able to provide that lineage.
Do either of the deployment patterns that you mentioned, do either of them work better with changing dependencies between environments?
Yeah, so honestly, I would say deploy code works better for that, especially if you're changing dependencies through a requirements.txt file. That's just a file that you're versioning with the rest of your code in a repository. So I'd say, like, if anything, that's gonna be a little bit easier. The model binary, it's somewhat limiting if that's a fixed thing that you're moving, and it's hard to access, like, again, the dependencies in there. So I would say the deploy code is a little bit more conducive for managing different environments or dependencies across different environments.
Any more questions? One question I had was, what was the moment where that CI/CD fear was kind of alleviated?
It's still there sometimes, yeah. I'll let you know.
Awesome. Well, thank you so much, Mary Grace.
Thank you.